These are the 1HH notes on distributive property using area. The distributive property can be related to the area of a rectangle in order to help you better understand how to use the distributive property. Let's look at the first question. We are trying to find the area of the rectangle. In order to find the area of a rectangle, you need to take the length times the width. So in this case, it's 20. Looking at question 2, this time the length is represented by a variable. So the area of that rectangle would be 7 times m, or 7m. In question 3, it's very similar. The area of the rectangle is 3 times a, or 3a. In question 4, we have variables on both sides of the square. X times x is represented by x squared for the area. In the next section, you have to find the area of each box in the pair. Notice that the length of this rectangle is labeled 4, but it's not labeled here on the other rectangle. You can tell that they're the same length, so you'll use that 4 in both of the rectangles. The area of the first rectangle is 4x. And the area of the second rectangle is 12. You get that by taking 3 times 4. We'll do the same thing in questions 6 and 7. In question 6, the area of the first rectangle is 7a. And the area of the second rectangle is 63. In question 7, the area of the first rectangle is x squared. And the area of the second rectangle is 2x. In questions 8, 9, and 10, we are trying to find an expression that represents the total length of a segment. So in question 8, if we have a segment that has a portion with a length of x and a portion with a length of 9, in order to find the total length, we would need to add those together to get a total length of x plus 9. In question 9, the total length of the segment is x plus 4. Try number 10. The total length for number 10 is a plus 2. Now in questions 11, 12, and 13, we'll put that information together in order to help you have a better understanding of the distributive property. First, find the area of each rectangle inside of the whole rectangle. For example, in this first one, the area inside is 5x on the left side, and on the right side is 35. Because in order to find the area of this one, we take x times 5, and for the second rectangle, 7 times 5. Do the same thing in questions 12 and 13. In question 12, on the left side, the area of the first rectangle is x squared. The area of the second rectangle is 12x. And in question 13, the area of the first rectangle is a squared, and the area of the second rectangle is 8a. The areas can be represented in two different ways, and this demonstrates the distributive property. We can express the area of this rectangle as a product. Remember in questions 8, 9, and 10, we talked about the fact that this length up here on the top of the rectangle could be represented by x plus 7, which means the area of the entire rectangle could be represented as a product, 5 times x plus 7. We could also represent the area as a sum, 5x plus 35. In question 12, we can do the same thing. The product of the rectangle would be represented by length times width, or x times x plus 12, or we could represent that exact same area as a sum, x squared plus 12x, where we're just adding together the areas of the two individual rectangles instead of finding the total area as an expression. Try number 13. The area can be represented as a product by taking a times a plus 8. It can be represented as a sum by taking a squared plus 8a. This process of writing these products as a sum uses the distributive property. Use the distributive property to rewrite each expression as a sum. You may want to draw a rectangle on a separate page to follow the technique above. So for the first one, what we're doing is instead of writing the area as a product, we're going to write it as a sum. In order to do that, we're actually going to take the number in front and multiply by the numbers inside. So 4 times x and then 4 times 7. When you do this, you end up getting 4x plus 28. Pause the video and try the next questions from 15 to 21. Then press play to check your answer. For question 15, the answer is 7x minus 21. 7 times x is 7x, and 7 times negative 3 is negative 21. Remember, subtracting 3 is the same thing as adding a negative 3. So when you're distributing, you're actually distributing and multiplying 7 by negative 3. Question 16 is negative 2x minus 8. You could also have negative 2x plus negative 8. Question 17 is x squared plus 9x. Question 18 is a squared minus a. You could have a squared minus 1a, but you don't need the 1 there. 19 is 3m squared plus 6m. Number 20 is negative 4x plus 16. Now the reason why it's plus 16 is because you're taking a negative 4 and multiplying it by negative 4 to get a positive 16. 21 is a squared minus 12a.